more shape properties, but yesterday we talked about properties of trapezoids. Trapezoids have one pair of parallel sides. And those, when we talk about the area equation, are the bases. Again, most of us have this filled out from yesterday. We're just going over it. Inside, you get same side interior angles. You get same side interior angles, which add to 180. Because again, a trapezoid, if you think about it, if you're intersecting, or if you've got a transversal, right, like this inside shape would technically be a trapezoid. And on these parallel lines, these angles are same side interior, these angles are same side interior. So you can kind of imagine it's all coming back to that transversal cutting of set of parallel lines. The property of isosceles trapezoids, we still have one pair of parallel sides. That's still the same. But an isosceles trapezoid, we add in one pair of congruent sides, which makes, if we draw it in here, which makes these bases opposite those sides also congruent. Think back to our isosceles triangle properties. Very similar. If I've got two sides that are congruent, the opposite angles will be congruent, those base angles. That was a recap of what we did yesterday. Okay? Today, we're going to focus on special parallelograms. So we have to keep in mind all the properties of parallelograms. Are we ready for the next one? Page 11. 11.4. Special parallelograms. So those 5 properties we still will keep in mind. If you forgot what they are, you could flip back to 11.2. Quick notes. Today we'll look at special parallelograms. That would be squares, rectangles, rhombi. Rhombi is the plural of rhombus. And we'll see what additional properties we can find. So first and number 1, I just want you to brainstorm with your partner. What properties do squares, rectangles, and rhombi all share, and why? So come up with a list with your partner. Brainstorm it together. If you don't have a partner, because people are absent today, find a partner. Ready, set, go. What are the properties they all share? Well, it's going to be those 5 properties of parallelograms, right? Because a square, a rectangle, and a rhombus is technically a special parallelogram. So we've got opposite sides are congruent. We've got our 4 angles add to what? Quadrilaterals. The interior angle sum is always 360. Opposite angles are congruent. And the list goes on. Consecutive angles add to 180. Opposite sides are parallel. Diagonals cross at the midpoint. These are all the things that a square, a rectangle, and a rhombus have in common. Questions? A rectangle has 4 right angles. For 90-degree angles. What's unique about a rhombus?
Congruent sides.
Good. 4 congruent sides. Rhombus has 4 congruent sides. All right. Now we're getting to the drawing part where you need your ruler. A rectangle and rhombus are shown. Use a straight edge to draw both diagonals for each shape. What do you notice? What do you wonder? Be ready to share with the class. So again, you're going to draw on the diagonals. Start thinking about the angles. Start thinking about the relationships. Start thinking about the shapes you create inside. So if you're not sure, we're going to draw in the diagonals with a straight edge. And then I want you to brainstorm with your partner. What do you think is happening? What's being created inside? What kind of angles? What kind of shapes? There's triangles. Do me a favor. Will you measure your diagonals? Will you measure them? Try centimeters. What do you notice? Measure them. Centimeters would be helpful. What do you notice about the rectangles, diagonals? They're equal? Let's write that down. Diagonals are congruent. Diagonals are congruent. What about the rhombus? Are the diagonals congruent? No. So diagonals are congruent in a rectangle, not a rhombus. But look, in a rhombus, it creates 4 90-degree angles in the middle. So that means it creates 4 identical right triangles in the middle. 4 of them are created. So this means this angle and this angle are congruent, and this angle and this angle are congruent. We've bisected those angles. These angles are congruent. These angles are congruent. We created 4 identical right triangles. In the rectangle, the diagonals are congruent. Because it's in a parallelogram, what do we also know about diagonals? Parallelograms. These are very special parallelograms. What do we know about the diagonals? They cross at the midpoint. They bisect each other. So that is still true. So in the rectangle, it actually creates some congruent triangles. So the top triangle and the bottom triangle, those are congruent. So the top and bottom triangle are congruent. The left and the right triangles are also congruent. But it's different from a rhombus. A rhombus creates 4 identical right triangles. And a rectangle, you've got 2 pairs of congruent triangles. Do we see it? Do we see the relationships? Cool. We've gotten to number 4 where it says stop. So now that we listed all these properties, right? We've got a lot of properties listed in 1, 2, and 3. I want you to determine for each statement, does it describe a rectangle, a rhombus, both, or neither? And I want you to decide with your partner. Read through A through E and decide. A through E and decide. Now that we listed all the properties. Ready, set, go. With your partner. Rectangle. What about B? What do you think? Now it's talking about each like vertex point. So like the corners. Does that change your answer? It's neither. It's neither. How about diagonals cut the 4 vertex angles in half? Rectangle. It really doesn't cut them in half. Which one does it do it in? A rhombus. So be careful. Diagonals don't cut those angles in half in a rectangle, but it does in a rhombus. Part D. A single diagonal creates two congruent triangles.
Both.
It's actually both. Both would create two congruent triangles. And E. Diagonals create four congruent triangles. Which one's that? A rhombus. Interesting. 5. Which of these properties does a square have? What do you think? Good. All of them. A, B, C, D, and E. All of them. So when you're getting really specific about a square, remember all these things happen. Especially B. If I were to draw a square, this is going to come up in your homework, right? When I draw in diagonals on a square, we are cutting those 90-degree angles perfectly in half. But we've talked about that. And 45 triangles show up in the middle. We've talked about that. I might make a special note because this is going to come up on your homework and your test. Are you ready for the quick notes? You ready? Flip the page. We're going to summarize what we saw here. I'm not going to make us write out all those properties again. Again, there was a lot of properties we wrote out in 1, 2, and 3. I'm not going to write them all out again. I'm going to highlight the important ones. Rectangles. Rectangles have congruent diagonals. And again, I don't want us to forget the diagonals bisect each other. Just want to remind you the area formula for a rhombus is half times diagonal 1 times diagonal 2. We saw that in lesson 11.3, but there's your reminder. When we draw on the diagonals on a rhombus, they are perpendicular because it creates those four identical right triangles. And it'll bisect those vertex angles at the corners of your shape. Cool? Squares have all the properties. Of rectangles and rhombus.
Because that one's 23, 2 is an alternate interior equal to that, so they're the same.
Remember, you've got all those properties of parallelograms because these are just special parallelograms. So in number 1, angle 2 should be 23 because it's AIA. It's alternate interior angles. Remember, you also have, you've got some congruent triangles. So this will help you find angle 3. Angle 3. Wait. And the next one, you've got rectangle ABCD. It tells you DW is 6, BC is 11. Find the other segments. How'd I get 67? No, the whole thing is a right angle. So I did 90 minus 23. They're complementary. Remember that word? You're told DW is 6. Remember, diagonals on a parallelogram bisect each other. Diagonals in a rectangle are congruent. So this has to be 6, which means this whole segment is 12. DB is 12. It told us BC is 11. Find AB. Any ideas on how we're going to find AB? I highlighted something there. A triangle? Specifically, what type of triangle? A right triangle, and we know the whole diagonal, the hypotenuse is 11. One of the legs is 11. The hypotenuse is 12. Here we go. Pythag theorem. It keeps coming back. So you're solving for that leg A. We can solve for that one. It does come down to the square root of 23, which is like 4.79, so you would round to 4.8. Or you could just leave it in the root form. Remember, this is exact form. This is approximate form. Remember that language. All right, we did it. We've got one more lesson on kites tomorrow.